So we have to find the stability of the system which is given by this characteristic equation. Okay, so we have to form the Routh array. Routh array can be found so this is 1, 5, 8, and this is 4. This is 3, 9, 6. Okay, and this is 0. So how this element, first element, can be found? So in previous example, we have seen that we have got the first element of one row 0. So when one row having the 0 element in its first position, then what will happen? Your Routh array will break down. We cannot continue further. Okay. So we have replaced 0 by the epsilon and we have continued the Routh array. So let us check here whether we got here this is 3 into 5, 15 minus 9 by 3. Okay, so 6 by 3. So we are coming here. It is 2 is coming here. And this is next element is 3 into 8 minus 6 by 3. So this is 18 by 3. So this is coming here 6. Okay. Now this element we have to find is 3 into 4, 12 minus 0 by 3. So 12 by 3, what is coming? 4. So here it is coming 4. Okay. So the next element is there. As we have to find these elements. So 9 into 2, this is 18 minus 6 into 3, 18 by 2. So we have got here 0. We have got here 0. Again 6 into 12, 6 into 2, 12 minus 4 into 3, 12 divided by 2. This element we also got 0 and this is also 0. So we have got one more difficulty in forming the Routh array. What is difficulty? In previous example, we have seen that the first element of one row becomes 0 and we have replaced it by epsilon. But here all the elements are here 0 of this row. All the elements are 0. We can see here rows of zeros. Okay, so all the elements of this is become 0. So see, when the Routh array, all the elements in any row in the Routh arrays are 0, then we have to form the auxiliary polynomial using the elements in the row just above the rows of 0. So the auxiliary polynomial we can write just above this. So the order of the auxiliary polynomial is always even. So this is your auxiliary polynomial. So s raised 2s raised to power 4 plus 6 s raised to power 6 s square plus 4 is equal to 0. And we have to differentiate this with respect to the, so this is auxiliary polynomial and we have to this is auxiliary polynomial, we have to differentiate it equal to 0. Differentiate with respect to the s and equate it to the 0. So this is 8s cube plus this 12s. Okay, so this is the differential. After differentiating, we have got these equations and we have to replace these rows of zeros by the coefficient of this equation, differential equations. So replace the rows of 0 by the coefficients of this auxiliary equation. So instead of this 0, we have to replace it by 8. Okay, and here it will be 12. Okay, and the this next is here 0, so it will be the 0. So in this way we have replaced the rows of 0 by the auxiliary polynomial. We have considered the auxiliary polynomial equation just above the rows, which is just above the 0 rows, and we have differentiated that with respect to the s. After differentiating whatever the equations we have got, replace the 0 by the coefficient of that equation. Okay, now it is over. We have got the rows. We have replaced the 0 by the coefficient of this equation. And we can now continue further the Routh array. So this problem is also over. Now we'll find s raised to power 2. So what is s raised to power 2? 8 into 6 minus by 8. This element is coming, this is 3. Okay, so this is 8 to the 24 minus 0 by 8. This is also coming 3. This is, sorry, this is not, sorry, this is, so there, here it should be the, so this is coming not 48, mistake is there. So 8 4s are 8 into 4 minus 2 into 0 by 8. Okay, so this is 4. This should be the 4, not 3. This is 4. Okay, next is we have to form s raised to power 1. So this 12 into 3 minus 8 into 4 divided by 3. This is 22 divided by 3. So this is the 4 by 3. 4 by 3, and this is 0. And s raised to power 0, we have to write it from the, this is s raised to power 0. So s raised to power 0 is 4. Okay, so now your Routh array has been formed. Your Routh array has been formed, and we have to find, we have to check the sign of the first column. So this is the first column. This is 1 3 2 8 3 4 by 3 4. So we can see here all the elements are here positive. We can check here. This is your first column, and the signs of all the elements in the first columns are positive. It means that your system is having the roots that lie on the left half plane, and your system is stable. All the roots lie on left half plane and system is stable. No, not we. No, this is, we cannot we cannot say whether this system is stable or not, because we have got here the error. What error we have got? What difficulty we have got? Here we have got the 0. Initially we have got 0 here. So we have to, these rows of 0 we have replaced by the auxiliary polynomial equation. So we have considered this auxiliary polynomial equation and we have to differentiate with respect to the s, and after differentiation, whatever the coefficient of that equation we have written here. So, and then we have continued the Routh array. Therefore, at this stage, we can conclude that even though all the signs are positive, that means we have to check here the auxiliary equations we have got here. Auxiliary equation is A of s is equal to this 2s raised to power 4 plus 6s square plus 4. These equations we have got auxiliary equation, and now we have to find the roots of this equation. So we have to find the roots of this equation, and the roots of these equations, if you find, we'll get the roots of this equation are s is equal to plus minus j and plus minus root 2. Okay, means there are 4 roots lying on the imaginary axis. The 4 roots lying on the imaginary axis, hence the system is limitedly stable. Okay, this is 4 roots, they are lying on the imaginary axis. Therefore, we can conclude that the 4 roots are lying on imaginary axis, and hence system is limitedly stable. Okay, thank you for watching the video.